Hello. Today's lesson is about behaviors around asymptotes and holes. Our essential question is, how do we determine the behaviors around asymptotes and holes in our function? First thing I want you to recall is that in behaviors refer to what y is doing when x approaches a particular value. Also recall that within behaviors you do not always read the graph from left to right. So let's go ahead and start with our first example. We want to determine the behaviors around the holes and asymptotes of f of x equals x squared minus 4x minus 12 over x squared minus 5x minus 6. So our first step is to find out where the holes and asymptotes are, and then we're going to sketch what the graph looks like. So let's go ahead and determine these features. So number one, let's find the holes. Before I can do any of that, I've got to take my function and I need to factor it. So if I factor the numerator, 12 has factors of 1 and 12, 2 and 6, 3 and 4. And so the pair that subtracts to give me 4 is 6 and 2. So that's the pair I'm going to use. So we've got x and x, 2 and 6, and we need excuse me, we need a negative 4. So we're going to make the 6 negative and the 2 positive. So the numerator is factored. Now we're going to factor the denominator. So we take x squared minus 5x minus 6, x times x. 6 is factors of 1 and 6, and 2 and 3. We need the pair that subtracts to give us 5, so we're going to use the 1 and the 6. And we need a negative 5 in the middle, so we're going to make the 6 negative and the 1 positive. So now that I have it factored, remember that a hole is located where we have factors that cancel out. So we're going to have x minus 6 that's going to cancel in the top and in the bottom. So our hole will be located where the x minus 6 is equal to 0. So at the value of x equals 6. Now the second thing I want to do is I need to figure out, remember, a hole is a point. It's not just an x value, it's not an equation, x equals 6. It's a point, so we also need to figure out the y value of our holes. So what I'm going to do is take what's left over, x plus 2, over x plus 1. We're going to plug in the 6 value that we got for x into that equation, and we're going to see what the corresponding y value is. So if I plug in 6 plus 2 in the numerator and 6 plus 1 in the denominator, I'm going to get a value of 8 over 7. So our actual point, or ordered pair, is 6, 8 over 7. Go ahead and pause and copy this down, and then we'll continue with the rest of the problem. Okay, so we have determined the whole of our rational function. Now we're going to determine our vertical asymptote. Remember, the vertical asymptote is whatever factor we have left over in the denominator set equal to 0. So we're going to take the x plus 1, set it equal to 0, and we get a value of x is equal to negative 1 when we solve that. So x equals negative 1 is our vertical asymptote. From there, let's go ahead and finish figuring out other things that will help us to sketch the graph. So the third thing we're going to determine is our horizontal asymptote. This one will have a horizontal asymptote because you'll notice that the degree of the numerator and the degree of the denominator are identical. The degree of the numerator is 2. The degree of the denominator is also 2. So degree of numerator, degree of denominator are equal, which means we will have a horizontal asymptote located at the lead coefficient of the numerator over the lead coefficient of the denominator. The lead coefficient of the numerator is 1. The lead coefficient of the denominator is also 1. So we will have a horizontal asymptote at 1 over 1, which is equal to 1. So horizontal asymptote is y equals 1. Go ahead and record this section of your notes, and we will continue with the problem. Because we have a horizontal asymptote, there is no slant asymptote. X-intercept is going to be found at the factor in the numerator that was left over, which was x plus 2, the one that didn't factor or didn't cancel out. So we're going to take x plus 2, we're going to set it equal to 0, and when we solve that, we get that our x-intercept is x equals negative 2. To make that an ordered pair, just put 0 at the end of it, and so we have an x-intercept at negative 2, 0. Now we can determine our y-intercept by taking our original function and plugging 0 in everywhere there's an x. So our original function was x squared minus 4x minus 12 over x squared minus 5x minus 6. So when we plug 0 in everywhere into the function, this will become 0, this will be 0, this is 0, this is 0, so we end up with negative 12 over negative 6, and that is equal to a positive 2. So that's our y-intercept. So writing that as an ordered pair, we get the y-intercept 0, 2. And now let's go ahead and start putting some of this stuff onto a graph. So looking at our information, we said on part A, one other thing that we haven't done, sorry. Our domain is going to be all real numbers, except where we have a hole and a vertical asymptote. So it's going to be all real numbers except x equals 6 and x equals negative 1. Alright, so let's go ahead and start graphing the information that we have. We have an x-intercept at negative 2, 0. So there's a point there. We have a y-intercept at 0, 2. We have a hole at 6, 8 sevenths. So 1, 2, 3, 4, 5, 6.
Back here?
Pardon that interruption. We have the hole is at 6, 8 sevenths. So 1, 2, 3, 4, 5, 6. 8 sevenths is a little bit more than 1. So we're going to put an open circle at that location. Our horizontal asymptote is at y equals 1. So right across here we have our horizontal asymptote. Our vertical asymptote is that x equals -1. There's our vertical asymptote. You can kind of see the two sections of the graph where the rational function will be located. It will be in the first quadrant, mainly in the first quadrant, and mainly in the third quadrant. So at this point, we now take our calculator and we figure out some other points to help us to finish graphing it. So let me go ahead and do that, and we'll pause and I'll come back with what the graph looks like. Okay, so I went on the calculator and I found these values for my table. 1 gave us a value of 1.5, 2 gave us a value of 1.33, 3, 1.25, and you can see that it's getting closer and closer to the y-asymptote, or the horizontal asymptote. So this other end, knowing what shape a rational function is going to continue to grow even more rapidly, and so we'll have the shape of our rational function. Remembering that this end is getting closer and closer to the horizontal asymptote, and the other end, and that's going up, is getting closer and closer to the vertical asymptote. On the other side, we have -3.5, we have -4.66666, and we have -5.75, and you'll notice that that also is getting closer and closer to the horizontal asymptote, whereas the opposite end is getting closer and closer to the vertical asymptote. So we have our typical rational function. Now again, at the whole, we put an open circle, and now we're going to determine the end behaviors, or the behaviors around the asymptotes and the holes. So let's go ahead and start with the left side of the function. And let's talk about the behaviors around the asymptotes. And let's start with the horizontal asymptote. As x is approaching -infinity, we're going to the left. Y is approaching the horizontal asymptote, which has a value of 1. And so as x is going to the left to -infinity, y is approaching, getting closer to the horizontal asymptote, which had a value of 1. On the other side, as x is going to +infinity, y is also approaching the horizontal asymptote, which has a value of 1. So on each end of the function, as it goes opposite directions to -infinity and +infinity, it is approaching the horizontal asymptote of 1. And as a matter of fact, you're always going to find that the end behaviors of the function, the two ends going to -infinity and +infinity in a rational function, will always be approaching the horizontal asymptote if it has one. Okay, so our next one, and so we can call those the end behaviors, because they really are the ends of the functions, from the negative side to the positive side of our domain. The next one, we'll talk about the behaviors around the vertical asymptote. Now on this one, x is approaching the value of the vertical asymptote, which is -1. So we're going to say that as x is approaching -1, y is going where? Where is y going as x is getting closer and closer to that -1? And hopefully you can see that y is continuing to go down, and it never stops. So y is going to, or approaching, negative infinity. From the right side of the function, and this would be talking about the left side of the vertical asymptote, as x...
Sorry, I don't know that.
You'll have to pardon the interruption. As x is approaching negative 1 from the right side, you'll notice that the function is going up forever, and so y is approaching positive infinity. So we talk about the behaviors around asymptotes and holes as being from the left or from the right, and so that's how we will distinguish which side we are talking about. So finally, let's talk about the behavior, or the behaviors around the hole. Our hole was at 6,8/7. So as x is approaching 6 from the left side, what value of y is it approaching? 8/7. As x is approaching 6 from the right side, if we were to come back this direction, as it's approaching 6, y is also approaching 8/7. And generally around holes, you'll find that the behaviors will be identical, but you still want to be able to talk about them as approaching from the left and approaching from the right. Go ahead and pause, finish taking your notes, and we'll talk more about this on Monday in class. Have a great weekend.